welcome to my talk, using F# on Azure Functions in production. Take note, this is how you get accepted at a conference. Just throw buzzwords at the title. More seriously though, there are a few things I hope you will be left with after this presentation. I won't be here saying like, yeah, we're running 500,000 functions and I built a Slack clone in my own time on serverless. This is not that kind of talk. What I hope you will be left with when the talk is over is how freaking awesome F# is and F# type providers. I hope you will have a nuanced view of what the Azure Functions can do and how you can work with it. And I'm going to be showing some Azure Functions 2.0 because that's coming now and it's cross-platform, the runtime and everything, so that's a bit cool. But I'm going to start about talking a bit about methodology, and because I'm going to show you a service we made to track changes between environments in our production pipeline. And I'm going to explain why the pipeline is like it is, the way we work. So I hope people will be left with a bit insight into what I think continuous delivery is and some goals you should aim at to achieve that. So it will be a fine mix of continuous delivery, F#, and Azure Functions. And I'm going to start simply by saying what I consider my job is. Love the resolution, but it says the goal is to get code running in production. And this is how I consider that's like my job title to me, get code running in production. I wish it said that on the contract I have with my employer. Should, but it doesn't. And when I go to work, I always aim to how can I improve this part of my day? Because if a feature is not in the hands of the customers or the users of your application, then you're not providing value. And if you wait until you deploy every Friday because it's a bit tedious to deploy and stuff like that, I would say you're not doing continuous delivery. If you're deploying 1,000 times a day, you're not necessarily doing continuous delivery unless you actually are providing value to your users. One thing we adopted, because this is our end goal to get features into production, is that we removed all kind of branching strategies. If you have a branching strategy, you have waste in your project. If you disagree with this, please contact me after. But if you're doing anything else than stable master, then you should aim to go to stable master. And we always work after this principle. The master branch is holy. It should always be ready to deploy to production. And the only other branches we have are local, short-lived feature branches that developers use on their machine. This is known as like the GitHub flow, stable master, has a lot of names. The way you do it, locally lived feature branch should never live more than like 3-4 days, I would say is the limit. If you're starting to make a feature on your machine that's taking you longer than that, you should find a way to merge it into master before continuing. The way you do that, of course, is with feature toggles. Feature toggles are a kind of technical debt because you need to make sure you have full control over them. You need to make sure that when you are done with that feature toggle, that you actually remove it and don't leave it there. But basically what you do is you put unfinished stuff into master, you deploy it to production, and with a toggle you hide it from the user. And then you can switch it on later straight in production without having to do a new deploy and stuff like this. But in its simplest form, it's just an if statement in your code. And you maybe do a new deploy with another environment setting to enable a feature. And the reason we get this to work and not fail all the time is peer reviews. Using the team members on our team, which are all very talented people in my team. And I'm the only reason we can catch bugs and stuff in this kind of lean, fast-going way of working is peer reviews. So our way from code to the dev environment, I'm going to change the resolution actually. That's a bit annoying that you can't see all the slides. We basically start with that we, as a developer, we start on our local machine. As I said, doing the feature. Let's see if this works. Better, yeah. It adjusts or something, whatever. We start on our own machine and we make the feature. Few days of work. Then I push to origin in Git. We use GitHub. I make a pull request. Added a cogwheel here. Of course, my pull request is built. And it won't go into master unless the build is green. I have a teammate that I go and I sit together with that person and we look through my code in the pull request. And then we're back again. Don't make too big pull requests because people are going to hate you if you come to them with like thousands of lines of code. So make sure that your pull requests are suitable pieces, like not too long, and that you can do a peer review in 10, 15 minutes maybe. We had some special things that we did in our team. Instead of having some kind of code analysis or something, we added a hashtag DB migration in the title of our pull request if we had made a database migration. And we also added an ID of related work items. So if we had a task we were tracking in Trello, in Jira, you usually have a key or ID. We made sure to put that in the title of the pull request. So when we merged the pull request after it built and got approved, both of those two things had to happen for you to get your code into master. Then the merge commit that GitHub makes is the name of the pull request. So then we would have a commit in Git in the source control saying if there was a DB migration in there and what kind of work item or card or whatever in your project management system you were actually, this code is connected to. Then master builds, artifact is made, and it's deployed to the first dev environment automatically. So for every pull request that comes in, we have an artifact that is a potential candidate for production. So the merge commit looks something like this. So we have the key here for our project management tool. We have a DB migration in this pull request. So we added a DB migration hashtag. And yeah, we have these checks passed. And with the new approver features of GitHub, you can actually lock this too. So we lock this. Unless somebody goes into your pull request other than you and clicks approve, you can't merge unless you are like an administrator of the GitHub account. And of course, this one, we use coded migrations because we were in a public company and we weren't able to go in production in the public cloud with our main like systems. The thing with private versus public companies is that private companies think about money. Public companies only think about their reputation. So they are a bit more conservative and a bit harder to fight on these things. So yeah, that's why we had coded migrations, because we were doing rolling deploys. We were deploying and migrating up the database. We weren't like creating new databases and copying over data, doing fancy cloud stuff. This was like we were doing our test environments in Azure. We were doing a lot of supported system around. We had customer-facing systems, but the main, like 3 big systems, I can say this was at the Norwegian Directorate for Education and Learning. So the systems were exam systems and national test systems, very important systems for Norwegian society, where I'm from, and also very important for the future of the directorate. They needed to have a good reputation, so they would get more money from the state, and it's all about that. So it goes into the first dev environment after master builds, and then we ran smoke tests, and we promoted if they pass to the test environment. Then we had some environments that we could like deploy versions to do a bit of testing. when testers were done and they're testing it in one of the test environments, they put it in the QA. So when I say testers, that was actually us and people on our team. So when we felt like we had something we wanted out or the customer wanted out, we put it in QA and the customer wanted to check it themselves there. And that's where it kind of went a bit slow, like a bit of a choke, because they were it was so important to them that it didn't go anything wrong in production. They didn't want to fail fast in production and do all this lean stuff. They wanted production to be stable, but they still wanted to do continuous delivery. So they were a bit thorough here in the testing. And in the start, it went very slow, but in the end, it went super smooth. And the app we're going to be looking at after is a result of that too. It meant that we maybe deployed 2-3 times a week. We were rigged to deploy several times a day if we wanted, but because of this wish from the customer to be a bit conservative in production, we deployed when we felt we had good features for the users, and we didn't deploy maybe small infrastructural changes and stuff. We did that maybe together with the features. So not ideal, because we weren't then continuously delivering our platform maybe as much as we should, but features went out as soon as they were ready. And after a year or two, the customer was like, he could come to us, we would make something, and we would go from creating the code to being in production in 20 minutes. So when the customer understood what was possible, then we really got to see how positive it was to have all of this automated and this pipeline set up. But then we came into a problem because we were here in the QA to prod environment, and we got asked like, yeah, but what actually changes if we put this package, I know this feature I want is in this package, but we were 15 people on the team. So there's probably something more here. If the numbers go a bit up, the versions, it's probably a bit more in this package than just this feature I want out. So we started asking ourselves, how can we find out what is in this package? And we had kind of a mantra in the project that we should go from doing something manually to scripting it to automating it. So in the start, someone was doing research and making an Excel sheet here. And we had meetings with the customer where they said, go, no go, for deploy to production. That was like in the start. And now, when we deploy to QA, a changelog is automatically generated and emailed to the customer. And he just has to say yes or no, with links to Jira cases, with merge commits. Everything is in that changelog, and we're going to look at that. So what are we deploying to production? That's like the thing I wanted to solve. Because we are delivering so fast, we can't do this manually. We need something automated that shows us what we're deploying. So I was thinking of it like a bit more as code. I have two environments, QA and production. It was the most usual case for a given project. And a project was like a system or, yeah. So I basically thought of it like this. I want to know, given X and Y and Z here, I should be able to find out which artifacts are in QA and production. And knowing then which versions are there, I should be able to find the differences between them based on the way we worked on this. And I should also be able to know if there are database migrations, because we tag that. And I should also be able to get some information about what work items are being worked on here. So I was thinking, okay, let's make like a big black box that takes in these three arguments and returns a changelog. I made like a slide, like, why do all this that I'm going to show you now? Because most people, they just put into maybe their deployment pipeline, like a step in Octopus deploy, or they do a Git changelog. There are a lot of good libraries that can generate changelogs from Git. But the thing is, I didn't want anything in our pipeline, because we consider our pipeline as a production system, because if that one goes down, we can't Of course, we can deploy, but this is the way we do it for everything. Bugs, bug fixes, and features, we deploy the same way. No differences there. And it shouldn't be. If you're fixing bugs another way than you are doing normal deploys, you're doing something wrong. You should just remove the normal way and do everything the bug way and automate around that, because that's probably the faster and better way. So this function, then, to achieve all these things, it needs to find out, like I said, what versions are deployed to X and Y. What are the changes between those two versions? We need to parse those changes, because that will most likely be merge commits and stuff for this hashtag and work items. And then we need to go to like a project management system and find out more about these key project management tool keys that are mentioned, and then generate our changelog. So in our case, and I don't think that I feel like that's an implementation detail, but we used Octopus Deploy for handling the artifacts and deploying to environments. We had TeamCity that did the builds that made the artifacts. So I didn't have to use Git because TeamCity has an API on top of Git. So awesome. And we used Jira for project management. So those are the three systems I had to integrate with to have a changelog generator on the side of our deployment pipeline, to not add this complexity into the deployment pipeline itself. And when we started on this, we knew that F# was the right tool for the job, because we had done a very big system for the directorate in pure F#, which had rule engines, DSLs, domain-specific languages. It used SQL and JSON type provider. I'll get a bit more into type providers after. And we discovered that F# let us write more, solve more complex problems with less code and less errors. And that's kind of what problems we felt F# solved for us. Because we knew this because of the previous project, and I hear people saying this all the time, like I'm doing now. Maybe if you haven't worked with a functional programming language like F#, then you might not know, and you just hear people talking about it. But we knew, we had experience from this first point. Another thing we loved about F# was that we had option types instead of null, so we didn't have to have any null handling, because everything was either something of a value or none. And you were forced to handle those two cases all the time. And the type system in F# is extremely powerful, letting you make aliases and stuff like this, so you end up having a type-safe system. If you have a ID that is a GUID, you don't use GUID in the input to your function. You make an alias for GUID that is like changelog ID, terrible name, terrible example. So you make a type alias for GUID, so that if you have two GUIDs coming in as the first and second parameter of a function, you never mix them, because they are two different types, even though they are just aliases for GUID. And we do this in C# too. It's just that then you have to write pretty advanced, in my opinion, classes. You have to really work for it to get that kind of type safety. And the same with F# records, which are kind of like classes or objects holding stuff in F#. They are basically an idiomatic C# class, which means everything goes into the constructor and there are no setters. You have to make a new object, because of course F# is a functional language all about immutability and recursion and all these things. But so we get help from the type system, so we don't do mistakes, compile time errors. We don't have to handle null. That kind of is what resulted in the top point here. We also had a lot of experience with using F# make or fake as our build system. And a lot of people use Cake, C# make, or Sake, PowerShell make. But F# make is bigger, has more contributors, and most important thing of all, it has auto-completion in Visual Studio Code and other editors because it's 100% valid F# scripting, because F# is a scripting language on top of being a normal language on the .NET platform. So I would recommend you on your next project, we use this even if it was big C# projects, we used F# make as the build system because it's a DSL, so it doesn't really have anything with F# to do with F#. You can still utilize, if you know F#, you can utilize all the pluses that you know, but it's still better than Cake or Sake. If you disagree with me, come talk with me after, please. Type providers, and this is why we chose F# most of all for the task, because remember, we are integrating now with 3 different APIs. That's a lot of everything is returning JSON. So how are we going to do it? Are we going to like or generate our C# classes, or are we going to handwrite what we need and then parse like dynamically from JSON into these classes? When the JSON response changes, we get a runtime error. This is and always has been hard integrating with other systems. But what type providers give you, basically, just look away from all this swada that is here. And what type providers give you is lazy generated types. So what it basically means in practice is that if I load a JSON endpoint, if I call a JSON endpoint using the JSON type provider, I just magically get type safety. I get classes. I can do root object dot and Jira issue dot status dot like all this stuff. I just get magically in my IDE, and I also get compile time errors if my code doesn't match the JSON. So let's say that you actually build against the real endpoint, your build will fail locally if you are not, if you have a typo or anything, and you don't have to regenerate classes if the endpoint changes its response. And we'll see a type provider code. Because we were here before, we were using Dapper in our C# solution, and as you can see here, it's very easy to read and understand what it does, for technical people at least. Basically, it selects some data from a table, given a where statement, and executes that, passes in a string, and runs the query, maps it to an object. But what we discovered with Dapper is that we have to write a lot of tests, because this is just a string, and if I have a typo here, it won't catch. It won't catch when I compile, and I won't catch that until we run it. So I have to write an integration test to actually test that I wrote correct SQL. We have an anonymous object here, so I can have a typo here, and if that doesn't match this one, runtime error, not compile time error. And of course, we don't know if anything is returned, so when we return first or default here, the method mapping this, of course, needs to have a null check. So we decided that this is a bit counterproductive to have to do all these things. This isn't things that are bringing value when I'm writing it. I'm doing it because I have to make sure, just to make sure that the valuable stuff works. And I just wanted that to just magically happen. So that's why we decided in the big tests system that we had, that we decided that the whole data layer shouldn't be Dapper. We should use the SQL client type provider for F#. And the next slide is the same code as the Dapper code. But now you're thinking, what? You said it would be less code and less errors. Well, I have an explanation for that, and that is that C#, F# interoperability, because you can call F# from C# code. And that is pain. I would recommend doing maybe F# for your data layer because of the reasons I'm going to explain. But working with C# and F# in the same solution I wouldn't recommend it. Other for big valuable things. The solution, of course, is to write F# for your whole project. So C# F# interop is a bit of pain, and we learned that a bit the hard way. What I mean with pain is especially that we have to map option types to null for C# to understand that there is nothing being returned. Visual Studio has a lot of problems with navigation between F# and C#. You get to the top of the file in F# and you don't know which line you were supposed to go to. And in Visual Studio Code, of course, there is the F# plugin is community made, and the C# plugin is Microsoft. Well, not originally, but now it's Microsoft, and they are not talking together. So there you have no interoperability at all in Visual Studio Code. The best IDE for interoperability is JetBrains Rider. Just works because the same people are working on the tool. They're working on both languages. That's how you have to do it. So I just want to go back to this one and say the most simple example of why F# typewriter is valuable. If I remove the R here, I will get a red squiggly line right away in my IDE saying to me that, hey, this doesn't match what you're trying to do. If I have a typo here, it would say, hey, this table doesn't exist. If I have a typo up here, it would say, that column doesn't exist, just as I'm doing it. So this looks like a string, and it is a string, but it's evaluated against the database schema while on your local machine. So you need to have SQL Express or something running the database, but you do that anyway. So you get that safety. And all this stuff down here has a lot to do with the interoperability. But since I was using a string in in this one, this is a string. So then the method here will automatically say, I need a string. If I had two clauses in my where case here, where one was a GUID in the database or a unique identifier or whatever, and the other was an int, the method here would say, I need a GUID and an int, because it knows what these columns are. So I get type safety when calling my database. I get security that my SQL statement is correct. And I was saying a bit about the interop stuff. This is because we have our domain classes in C#. Terrible mistake. We should have made those in F#. That's like the easiest way to start using F#. Write your like pure POCO domain objects in F#, and you get like idiomatic C# objects, but they are like super lean and small. And this, of course, is because of interop. This is because of interop between the async TPL in .NET that C# uses versus the async implementation of F#. So the reason it's also big is because we were doing C# F# interop. So we needed to have methods or functions like this that takes in an option and says that we had to map the none to null to make sure C# could handle it. So people often ask me, like, how did the team handle F#? Because, and I always give the answer, I just didn't teach them the mutable keyword. And then they kind of caught on by themselves. I would say it was very positive because people were actually seeing value right away with this, especially with all the SQL they were writing, that it didn't fail, and they didn't have to write as many tests as they used to. Now they could write tests that actually tested the business logic instead of the data access logic. You shouldn't have to write tests for that. And I have to say, my team was a lot of talented people, so they caught on very quickly. But I was I was impressed about how they handle it, and I think like being conservative with F#, because you don't think people want to learn it, I think that's wrong. And I think you might have to mentor your team a bit, but I think it's worth it in the end. You'll get a lot of pluses doing it. Okay, enough about F#. Let's speed up a bit and we can look at some code. We decided this function should be in F# because we're integrating with 3 systems, and we'll get the same kind of type safety with the JSON from these APIs as we did with this SQL. So we have a function, but we need some place to host it. So of course, then it feels natural to be talking about serverless, and especially in this case, functions as a service. You don't have to think about, of course, there are still servers running. It's just you don't have to think about them. You don't have to think about scaling, patching, uptime. You can basically outsource everything. You don't have to write middleware for your, or deploy it to a PaaS just to get one little bit of code running. So you can write just the code that brings the business value and then minimal effort to have it hosted. And I always think of it like this with all the services we're getting in the public cloud. Like, I have business value on the side here, and just as you move further this way, you can focus more on adding business value. So software as a service, everything done, that's the best one. You just take a component, email sending with SendGrid or something like this, genius. And you kind of go down like infrastructure, you still have to think about network and all these things like that I don't really care about. But the thing that is a bit like, what's the difference between these two? Because usually the serverless runs on the same compute as the PaaS. But the thing is, even less, you can look away from not only the platform, but you can look away from a lot of the code hosting, the configuration of hosting. I love this quote, like, if your PaaS can efficiently start instances in 20 milliseconds that run for half a second, then call it serverless. So that's also kind of the thing here. You have quick functions that can shoot out, like start right away, execute, and kill itself. And in the middle of the night, when no one is using your system, you have scaled efficiently down to 0. You can't do that with a PaaS. You have to have one instance running, ready to take that first request. Of course, can be a -2 because something has to be bootstrapped, so be aware of that. But basically, pay for what you use. You don't have to worry about scaling because it just goes in parallel. You can write code that solves business needs. But I'm a bit on this. Now it sounds like, oh, serverless. Yeah, it's the drop everything you're doing and do serverless. Well, I still think there is some things that serverless is the right direction, but we really need to change the way we think, and we need to change. We need better serverless services, in my opinion. I think Lambda and Azure Functions and everything is going in the right direction, but I don't think it's there yet. We have to think differently about how we handle state. We have to think about this latency and startup cost, if that is important to our system. One thing that is important to me is running locally on my machine, or more specific, the feedback loop as a developer. That's important to me, like all the tooling I use. If I have to have my own account in Azure or AWS and have a long feedback loop because everything is running in the cloud, then I'm a bit more skeptic. It has to be very good for me to think that is better than being able to run it on my machine. And of course, you have vendor lock-in. Like, the more you start using of the services of the cloud provider, the harder it is to change it for somewhere else. If they put up the price, if they change their terms, if they don't comply to rules in your country, all this stuff. But that, I think, is a very specific problem. I think for most people, that doesn't matter. It's worth doing the lock-in. And we'll get a bit back to that. Like, don't write your code so you are locked in. Keep doing modules, keep doing separation of concerns, and then it's only a small part that is actually locked. So we had a deal with Azure in the company, so it was like the only option for us to use Azure Functions if we wanted to go for function as a service. Also, we were doing F#, and F# is a Microsoft language, and at the time, Azure Functions was the only one that had support for F#. The things I thought were cool is that I knew that the runtime was running on the Azure Web App Service, so I knew is battle tested. So then only the uncertain part for me was the runtime running on top of that, running the functions. The cool thing is that the runtime can run locally, and it's not an emulator. It's the real runtime. You can download it to your machine and work on it there. And it just became cross-platform. And it has a lot of triggers and integrations that you get for free with Azure SQL, with storage, all these things. So, okay. We have Azure Functions, we have F#. We should be able to solve our problems with this. And I know I love talking, so I'm gonna shut a bit up now, and we can look at some code, because everyone loves to look at some code. The thing I want to show is that when I decided to use F# to solve the problem, I just made a normal solution, and I make a normal library, because it doesn't have anything to do with the Azure function, what I'm actually trying to solve. So I'm making a module, a library. I'm using F#, and I have basically a simple entrance into my module. It is basically just a function that takes some arguments. The arguments are simple things. It's the three things that were the input to our function: the project name, the environment we're going from, and the environment we're going to. And it also takes some like URLs to TeamCity, to Octopus. All these things just come in there. It's not important. It also keeps like a small map of what is the project called in Octopus, what is it called in TeamCity, and what is it called in Jira. So we can map between these three. That is, if we were a bit smarter, we could have just like given it the same ID or the same name, but we didn't. So I'll show you just how the input looks. Basically, I have a mapping like this. And I can add more mappings, so I can use the changelog for all the projects we have in these systems. But basically, the master build that makes the artifact map to the deploy name in Octopus Deploy. I add the GitHub URL to the repo, so I can link up easily to GitHub, and a Jira key that we should parse for. So this is the input, together with what you see under all the URLs and stuff. So the first thing we do is we try to take the project name that we sent into the function and look up in the mapping and say, do I have in my mapping any way to, any knowledge of this project? And if we get a hit, and here you see the try find, that either gives us something or nothing. So if we get something back, we know here that we have it. If not, we just fail, because we can't do anything if we don't know about this project, because of this mapping problem that I was talking about. Then we call a function that's called get, the difference between the delta between these. I'm sorry, we actually skipped a step, didn't we? We had to do this first. We had to call Octopus Deploy and get the two versions. And this is just a function, and I'll show you, because it's the same for all three systems. If I go into this, let me script here. If I go into this function, we'll see it takes in the project name, the environment name, because we're asking for the version in a specific environment, and the base URL and API key that we just insert. We just make a header. We do a normal HTTP request against the API. But what's cool here is that I have this magic octo project list.parse method here. And that's because I have provided a sample of how the response from Octopus Deploy looks, how the JSON looks. I made it into a constant, and I provided it into the JSON type provider here, which gives me a strongly typed class of the JSON. So when I start using it down here, you can see that I can use these things like, if I check and I have the .name, I have the .id, things that are automatically just given to me from the type provider. So I get type safety accessing the JSON response from here. I just run it to the parse, and I have an object. And I don't have to handle that object. I don't have to update that object. I don't have to do anything. Then I just do another call to get the progression, blah, blah, blah. There are some difficult JSON maybe that it's not able to parse because it's maybe not valid JSON or anything. So then I can do like more advanced stuff. And I'm left with the version in that environment. And I haven't made any types or anything for this, and I have type safety against the API. So I do that for both of the environment, and I use that to get the difference, because then I have the two versions. I only have the name of the environments and the project. Now I've gone from having the name of the environments to having the version in these two environments. So then I can go on to calling Team City, and it's the same stuff, like using the type provider to get type safety. I have a sample of what it returns, and it's the same stuff that you saw earlier. I do some calls to the beautiful Team City API, and I know what to ask for because I got the version. And you see here, I have this build class. I choose to map it, but because it has a lot of stuff, and I just want the comments basically. But you see, I have .number, .status, and I didn't make any types. These are all automatically generated for me. And it's the same basically when you go against Jira, because what we do then is we just take the commit messages. We use some simple regex based on the mapping we created earlier, and we get all the keys. And we have another function that does the same, goes against the Jira API with full type safety using the JSON type provider. I don't have to generate classes or think about this stuff. And I get the Jira issues back. Then I can parse the comments for this DB migration tag, super easy stuff. And I can go through the merge requests to get a bit, so I can link them up to GitHub because I had the GitHub link. So now I'm just going through to find like the pull request number and trivial stuff. And in the end, I can return a type I made called changelog, which says which project it is, from version to version, what commits were here, what issues were here, and was there a database migration. And basically what I end up with is this one, with links and statuses from the Jira. And this is from right now. I'm not on this project anymore, but I had access. So, so I thought I'd just show it. And this is served, this that we're looking at now is actually served to a simple Azure function, which is like pre-compiled. This is Azure Functions 1.0. If you're going to work with that, you have to be on Windows, you have to be using Visual Studio, and you don't have to, but you should pre-compile all your functions, because it supports that you can compile on a build server on your machine and then just say what entry point to go into. So in this case, we had a run method that took in the parameters, and I just hook it up with this function.json file, and I provide the DLL, my DLL, and I have a small DLL that is the function itself. Typically, a function looks something like this. I can show you also that like it works. Here is a script where I just load in the DLLs I need, and I have the same things I used in my code. I can run it in the F# interactive, because F# is a scripting language as much as it is a programming language. And then you can see that this is the same changelog that we were watching, running the code that I just showed you. And I also have like a way to just get it to be HTML so we can present it. A typical function looks like this. Just do some hacky way of getting the 3 variables that is the input from the user. And I check that they are actually provided. I provide this bootstrapping of my library, and I call my library using those arguments. And this is how I think you should use functions. All your business logic and code should be in libraries or in modules and everything, because this isn't lock-in. I can change this to Lambda in 10 minutes probably. Another cool stuff, that's like if you want to serve everything from one function, but you can also do something like this easily. Here I do the same, but I have a simple type I've made that has name from environment to environment, and I simply return that from my function. And I have bindings in my function. And this is things I get like for free from Azure Functions. So it's saying I have a HTTP trigger, a GET request that I send with the parameters. I return a response right away, but I also put it on a queue. And I didn't write any logic here from putting it on a queue. I just provide this JSON file, and Azure Function just magically knows that the return value of my function should be put on a queue called changelog items. And then I have another function that basically just it just takes a message as an input and then writes that message, returns a string of that message. And so it's nothing, but everything is provided here in the functions file, where we can see that the input is a trigger on the queue. So the same output that was on the previous one, this one takes that as an input. So when something arrives on the queue, this function will trigger and give that message as an input to this function. And it will return by saving it to a blob. So the only code I wrote here was a function that took in a message and just returns it as a string. When I decide to run this, this is the cool thing, that I have the runtime locally. So I don't have to deploy this to Azure Functions or anything to get it to work. You see, I just start the host locally, get some addresses here. This was the first one I showed that did everything in one function. Then I have one that adds it to the queue. So I can go here and can do this. It's just call. I'm just calling the endpoint with normal HTTP. I can see that. I wanted to show this actually. Here you can see I'm getting a runtime error. And the reason for this is that my environment is not the same as the serverless environment. And I think this is important to think about. That they are telling you you don't have to think about the environment. But you do. You have to think about their environment. So this is just a heads up. I'm going to stop the host. I'm going to make sure that the queue function doesn't call my library, but just returns. I'm going to save that. We're going to do a .NET publish. What .NET publish does is that it copies, it doesn't only build my solution, but it publishes all the dependencies and everything into a folder. So you see here it's just a folder under my bin directory. And I'm in that folder now, just running this func host start. So I'm going to do the same thing now, and hopefully I haven't forgotten. So now we see that it's a bit hard to see because it's in the bottom, but it basically says, I received the HTTP request, I put it on the queue, and then the other function comes and says, hey, something was on the queue, I pulled it off the queue, and I saved it to blob storage. And I have the Azure Storage emulator running on my machine, so this isn't against storage in Azure. I could, if I wanted to test it there directly, but I just want to run it on my machine. So I've done that. And I can use the Storage Explorer to see that I have data in this blob. I can open it. Are you sure? Yes. Notepad. Okay. and you'll see that this is the message I sent in, or a message that the first function put on the queue. So I basically made like a async reactive system here with I didn't write any code, I just did some JSON. And now I can basically, if I want this kind of pattern for any library, I could basically just bootstrap my library in here. The runtime error you saw is because my version of F#, or I'm using a dependency that needs a higher version of F# than the one that Azure Function uses, and it won't let me provide my own without being a bit hackish. But this, in my opinion, is a problem that Azure Functions should solve and will solve. But then we're a bit back to, they are not prioritizing my F# case here. They are making right now the most. They want all their hello world examples to really pop. So that's what I was talking about. That I think we really need to like be a bit patient, because I think serverless is the future, but I think it has a long way to go too. And the cloud providers are saving us a lot of work, but the moment I hit a problem like this where I want to use F#, I want to use a specific version, and there's nothing I can do except try to hack my way around it. They won't prioritize this because they most likely have much more valuable stuff to use their time on. So that's like a catch. But I think it's important to realize that how the reusability of what I just showed you here, you can use that for anything that needs to be async, needs to be processed and then saved. And please still use the same principles as you use today with like separate out your business logic so that you can easily move this into whatever, a console app you want to run from your machine. Like the wrapping and the hosting shouldn't really matter here. And that's basically it. That's what I want you to be left with. Like, check out serverless, but be sure to like still use modules, still use the good principles that we do when we don't do serverless. So just be careful, okay? Thank you.